Good evening, students. I am J.AROCKIA ARULDOSS, Assistant Professor, Department of Mathematics, St.Joseph's College of Arts and Science, Cuddalore. Today we are going to see abstract algebra. In that particularly, we are going to see the definition and some results in rings. First, we see the definition of a ring. A non-empty set R is said to be an associative ring if in R there are defined two operations, namely plus and dot, satisfying the following conditions. First one, this R should be an abelian group under addition. Then under multiplication, it is closure, that is A dot B belongs to R for every A comma B belongs to R. Also it will satisfy associative property, that is A dot B dot C equal to A dot B dot C for every A comma B belongs to C. Along with that, it also satisfy distributive law, which is A dot B plus C equal to A dot B plus A dot C, or B plus C dot A equal to B dot A plus B dot C for every A comma B belongs to C. Set of all integers and set of all natural numbers and set of all real numbers are all some examples for rings. Now we see the definition of ring, unit ring. If the ring contains identity element with respect to multiplication, then it is called unit ring. That is for if 1 belongs to R and A dot 1 equal to A for every A belongs to R, then R is called a ring with unit element or unit ring. Also next we see the definition of commutative ring. If the ring satisfies the commutative property under multiplication, then it is said to be a commutative ring. That is for every A comma B belongs to R, if A dot B equal to B dot A, then R is called a commutative ring. Next we see the definition of division ring. A field with the commutative property is called a division ring. Set of all integers is an example for a division ring. Now we are going to see a theorem which has 5 conditions. In that, first we see the first condition. If R is a ring, then prove that for every A comma B belongs to R, A dot 0 or 0 equal to 0 dot A equal to 0. First we take A dot 0. This A dot 0 can be written as A dot 0 plus 0. Then by using distributive law, it can be written as A dot 0 plus A dot 0. And again by using left cancellation law under addition, A dot 0 it cancels. So we have 0 equal to A dot 0, which means A dot 0 equal to 0. Similarly, 0 dot A equal to 0. And the second one is A dot minus B equal to minus A dot B equal to minus of A dot B. For this, we use the first condition, that is A dot 0 equal to 0. This A dot 0 can be written as A dot minus B plus B. Then by distributive law, this A dot minus B plus B can be written as A dot minus B plus A dot B. In the left hand side we have 0. Now we add minus of A dot B in both sides. So we have 0 plus minus of A dot B equal to A dot minus B plus A dot B minus A dot B. In the right hand side, this A dot B minus A dot B gets cancelled. Therefore we have minus of A dot B equal to A dot minus B. And therefore A dot minus B equal to minus of A dot B. Similarly we can say minus of A dot B equal to minus of A dot B. And the third one is minus of A dot minus of B equal to simply A dot B. That's what we are going to prove. For this we use the second condition. We know that A dot minus of B equal to minus of A dot B. So instead of A and B, we use minus A and minus B. So from minus of B, I take the minus outside. Therefore, I get minus of A minus A dot B. And also from minus A also I am bringing A outside. So minus into minus of A dot B. We know that it is equal to A dot B. Therefore, minus A dot minus B equal to A dot B. Third one is proved. And fourth one, minus 1 dot A equal to minus of 1 dot A, which is equal to minus A. For this also I use the second condition, that is instead of B I use minus 1. Minus 1 dot A equal to, I can bring the minus outside, therefore minus 1 into A, which is equal to minus A. So similarly I can say that minus A dot 1 equal to minus A, and the fourth one is proved. And finally the fifth one, minus 1 dot minus 1 equal to 1. For this I use the third condition, that is minus A dot minus B equal to A dot B. So I bring the minus outside in both 1, therefore minus of minus 1 dot 1, which is equal to 1. So all the 5 conditions are verified. Thank you.